This is May 19, paper 1, SL, time zone 2, question 10. If we're looking at this question, we see that y equals x cubed plus x, the whole thing, to the 3/2 root. And we want to find the derivative. So this is going to be an application of the chain rule because we have a composite function where f of x is equal to the parent function, and that's just whatever's in the parentheses to the 3/2. G of x is the inside function, and that's x cubed plus x. So that y is equal to f of g of x, and y prime is going to be where you derive the mom, you keep the baby, and then you derive the baby. So that in this case, if I do this, what I'll get is y prime will be, I derive the mom, I keep the baby. Remember the 1/2, 3/2 minus 1, and then I derive the baby. That's 3x squared plus 1. And I can write this a little bit differently, and I'm going to just because if we see the next question right here, the format's a tiny bit different, but it looks like a very similar question. So let me take all this stuff right here and just kind of shrink it. And we're going to focus on what we found right here, where we can agree that we found that y prime is equal to this. Okay, and it's to the 1/2, I believe. All right, and this can be rewritten then as 3/2, 3x squared plus 1, x cubed plus x. And you should see that this right here is identical to this part right here. The main difference is here, we've got a 3/2. When we're integrating, this is the derivative of the function we're looking for. The function we're looking for is called the antiderivative. When we derived our original function, we found the derivative. Notice that the derivative of y here, this one, is incredibly close to this. The only difference is this derivative does not have the 3/2 that we originally have. So that's going to mean that our antiderivative will be almost identical to y right here, but it's going to be such that this 3/2 will disappear. And the way that would happen is if we multiplied everything, our original function, by 2/3. So if this was our original function, then our derivative would look exactly like this. Which, in other words, if this is the derivative, then this will be the original function or the original antiderivative, which is what we're looking for. So we're going to find that, and we just want to make sure we remember the plus c. We could test this out, but I think we're okay. If you'd like to convince yourself, then you should totally take a second and derive this function right here and see that you indeed get this derivative right there. We're now moving on to part C. We've got the functions cube root x cubed plus x, and g of x is 6 minus 3x squared square root of x cubed plus x. And we see that g is this top function then, and f is this. These are unexpected roots. So be it. All right, we want to find an expression, so I'm going to put C right here because there's a little more space. An expression for the area. Well, the area is always going to be the integral, and I'm looking for R right here. So R is the area under all of G, but I'm subtracting the area under F, and I'm doing this from 0 to 1, right? From here to here, I'm taking all the stuff that's under G. This will be the blue stuff minus the red stuff, and that's going to be R, from 0 to 1 dx. And that's not really a mathematical statement, but the way I can find this is going to be g of x minus f of x dx, so from 0 to 1, and that's really the expression for the area of R. Now to find that actual expression, we can just solve for this. Notice, well, let me write this out. G of x is going to be 6 minus 3x squared x cubed plus x minus, and f of x is x cubed plus x. And there's a dx after all of it. Now, in this piece right here, well, that's unfortunate. In this piece right here, I've got a square root of x cubed plus x and a square root of x cubed plus x. So I'm going to factorize those two together. So that's 0 to 6 of 6 minus, this will be x cubed plus x times 3x squared plus 1 dx. Notice that if I multiply this by 3x squared, I get this part right here, and minus x root of x cubed plus x times 1 is right over here. So my pieces are all there. At which point, I can't really do a whole lot yet. Can I now? This does look like a u-sub. So now let's keep on going. I don't know how I got a 6 there. This should be a 1. Very well. So this can be 3x squared plus 1 dx plus 0 to 1, 6 dx. In this bottom part right here, we're going to use u-substitution. Let me make this a little smaller so I can have some space to show you what I mean. And the question is going to be, how do I know we're going to use u-substitution? Why is this process the right one? I think that's an important question to tackle right there. So if we have this, what you want to see is, and this is what will allow you to decide that u-substitution is appropriate. Here we have a function, and we have the derivative of that function within the same integral. I'm going to let u be the original function for u-substitution. So let's just try this. I'm going to say u is equal to x cubed plus x. So du over dx is going to equal to 3x squared plus 1. And du is going to equal 3x squared plus 1 dx. Which, if you'll notice, this piece right here is this and this. So I can now rewrite this as 0 to 1 minus root of u du plus 0 to 1 of 6 dx. Now, this is equal to minus 0 to 1 u to the 1/2 du plus, and here we can just solve this, 6x from 0 to 1. We need a tiny bit more space. I'm going to move these things up here. But I think we're basically there. So at this point, this is equal to minus u to the 3/2 divided by 3/2 from 0 to 1 plus 6 times 1 minus 6. And this will equal to, and u, let's remember, was equal to x cubed plus x. So now we have minus 2/3 x cubed plus x to the 3/2 from 0 to 1 plus 6. Well, at 1, this will equal minus 2/3 to the 3/2 minus, well, when I replace the x's with 0, it'll be 0 to whatever. And 0 to any power will stay 0. That's That's not something I need to worry about, so that this expression evaluated at f of b is just going to be 0. So I'm going to be left with 9 plus 6, minus 6 here. My plus 6. I'll take that back. Yes, very good. And now my question is 2 to the 3 halves. Well, 2 cubed is 8, and 2 cubed is 8. So this is the square root of 8. So I can do minus 2/3 times the square root of 8 plus, let's go for 18 over 3. And this is minus 4 root 2 plus 18 over 3. And I gather that's the exact area of R. Well, there we have it, folks. I hope this helped.